Welcome to the DIY Honda Garage channel. The DTC B1241, also referred to as DTC Indicator 59, indicates a problem in the blower motor circuit of the 2023 Honda Accord. This issue is detected when the blower fan feedback voltage fails to fall within the target range, prompting the climate control unit to recognize an abnormality. The primary components involved in this circuit include the blower motor relay, power transistor, blower motor, and climate control unit. These components work synergistically to manage airflow and air conditioning within the vehicle. The blower motor relay controls power to the blower motor, while the power transistor modulates the voltage supplied to it. This electrical interaction occurs in various locations throughout the vehicle's dashboard and under its hood. Thus, understanding the circuitry is essential for effective troubleshooting. DTC B1241 relates specifically to the blower motor circuit that is integral for proper climate control within the Honda Accord. The blower motor, located in the dashboard area, is responsible for pushing air through the vehicle's heating and air conditioning system, ensuring passenger comfort. The blower motor relay, generally found near the engine bay, directs power to the blower motor, while the power transistor facilitates smooth voltage regulation. Should there be an electrical fault or malfunction in any of these components, it could lead to the blower motor not functioning as intended. The climate control unit, located on the center console, interfaces with these components and is equipped with sensors to monitor voltage feedback. When any component fails to operate within specified parameters, this DTC is triggered. The possible causes for the B1241 DTC include several electrical and mechanical failures. First, a faulty blower motor relay may prevent proper power delivery to the blower motor, thus affecting its operation. Next, a malfunctioning power transistor could lead to incorrect voltage regulation, resulting in the blower motor receiving inadequate power. Circuit problems, such as open or shorted wires, can also contribute to abnormal voltage readings. The blower motor itself might fail due to wear and tear or internal failures, while a compromised climate control unit can misinterpret feedback signal voltages. It's crucial to systematically assess these components to determine the precise cause of the DTC. Vehicles suffering from the B1241 code may exhibit several symptoms related to airflow and climate management. The most noticeable symptom is an inoperative blower motor, which means that no air is being circulated through the HVAC system. In some cases, the blower motor might operate erratically, leading to inconsistent airflow, which can impact comfort levels inside the vehicle. Additionally, the climate control system may not respond properly to user input, failing to adjust temperatures as requested, therefore diminishing overall user satisfaction. Identifying these symptoms promptly can help guide technicians toward effective troubleshooting strategies. Start the troubleshooting process for DTC B1241 by turning the vehicle to the on mode without starting the engine. This enables the vehicle's electrical systems and prepares them for diagnostic evaluation. Utilize the Honda Diagnostic System, HDS, to perform a self-diagnostic function. The HDS is a sophisticated tool that interfaces with the vehicle's onboard computer, allowing for detailed analysis of the climate control system and its components. It will provide valuable real-time data regarding the blower motor's performance and potentially indicate fault codes associated with the blower motor circuit. This first step is crucial as it establishes a baseline condition that facilitates further testing and inspection of the affected components. The next step involves a detailed examination of the blower motor relay. First, disconnect the blower motor relay from its socket to perform voltage and continuity tests as outlined in the diagnostic manual. After disconnection, check the female terminals in the relay socket for proper voltage supply and connection integrity. Use a multimeter to ensure that there are no open or short circuits present. Conducting these tests will confirm whether the relay is functioning correctly and whether it is capable of supplying sufficient power to the blower motor. Document your findings, as faulty relay conditions may necessitate replacement to ensure proper circuit functionality. Following the blower motor relay inspection, focus attention on the power transistor. Begin by disconnecting both the blower motor connector and the power transistor connector, allowing for direct access to the terminals. Similar to previous steps, employ a multimeter to conduct open short-circuit inspections on the BLWM wire. Verify the resistance reading. It should show less than 1 ohm when the circuit is closed. Additionally, conduct a shorted-to-ground inspection, where you should find a resistance greater than 1 mega-ohm for proper operation. If any anomalies are detected, the power transistor may require replacement to restore proper operation in the blower motor circuit. Once the power transistor has been assessed, the inspection turns to the external circuit, which encompasses the main connection points for the blower motor circuit. Prepare by ensuring that the power transistor and climate control unit connectors are disconnected. Use a multimeter to inspect for continuity in the ground, BLWV voltage signal, and BLWG ground control wires. The readings for each of these circuits should indicate less than 1 ohm. Any greater readings would indicate an open circuit. An appropriate troubleshooting would involve tracing back through the wiring harness to identify any breaks or damaged areas. Also, perform shorted-to-ground inspections to confirm that there are no unintended grounding issues that would disrupt normal circuit operation. Next in the troubleshooting hierarchy, conduct a functional inspection of the blower motor. Prepare for this step by ensuring that the power transistor connector remains disconnected, allowing safe testing without feedback interference. Use a jumper wire to connect the power transistor's terminal number 4 to the vehicle's body ground. Then turn the vehicle ignition to the on mode. If the blower motor is functioning correctly, it should run steadily. If it fails to operate while grounded this way, it indicates an internal failure in the blower motor itself, which may necessitate a replacement. Ensure thorough documentation of results for both functional assessments and any subsequent part replacements. Finally, if all prior inspections have indicated normal operation, thorough evaluation of the climate control unit is warranted. With the blower motor and associated components functioning correctly, shift focus to the climate control system. This inspection should determine if the climate control unit is indeed the cause of the fault detected by the DTC. Utilizing the HDS for comprehensive diagnostics can help clarify whether a fault exists within this core component. The climate control unit is responsible for interpreting the feedback from the blower motor and controlling operation. If determined to be defective, it will likely require replacement to restore overall climate control functionality. Once repairs or component replacements have been conducted, it is essential to verify that the issue has been resolved entirely. Start by clearing the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. Following this, conduct operational tests of the HVAC system to ensure that the blower motor and climate control interfaces are functioning as intended. This step confirms the completeness of the repair work, ensuring the blower motor now runs properly and that airflow is correctly directed as per user settings. This final verification phase is a critical part of the troubleshooting process and is necessary for ensuring trouble-free performance moving forward. To prevent recurrence of issues related to DTC B1241, it's advisable to conduct regular inspections of all associated wiring and connections to the blower motor circuit. Keeping an eye on the mechanical components including the blower motor and power transistor, can also help avoid future malfunctions. Additionally, a routine maintenance schedule for the vehicle's HVAC system, covering aspects such as filter changes and checking for obstructions, contributes to the smooth operation of climate control. Properly maintaining the systems will ensure no unnecessary strain is placed on electrical components, potentially prolonging their lifespan and reliability throughout the vehicle's use. In summary, troubleshooting DTC B1241 involves a systematic process beginning with vehicle diagnostics utilizing the HDS, followed by individual component examinations, including the blower motor relay, power transistor, and circuit integrity checks. Each component's functionality plays a pivotal role in the overall operation of the blower motor and climate control unit. Detecting and resolving the underlying issue requires meticulous attention to detail and thorough testing of all relevant systems. Following repair, it's crucial to conduct functional tests to ensure all systems work as intended. Implementing preventive maintenance practices will further enhance the longevity and reliability of the HVAC system, mitigating future DTC occurrences. Please like and subscribe to the channel. See you next time.